All right, as I talked about in the previous video, we're going to discuss higher order functions. So higher order functions are functions that do something in one line or a few lines that may otherwise take multiple lines or some type of while or for loop. Um, and they make things a lot more simpler. Not just that, but they probably have better performance. They probably use less resources than maybe if you did everything from scratch. And when you start writing more complicated um, or writing more complicated coding challenges or answering more complicated coding challenges, you're going to need to use higher order functions. So the types we're going to deal with, and it's not all of them, I'm pretty sure I'm missing a few, but this is just for the sake of getting you familiar with them. Um, the ones we're going to deal with are reduce, max, min, filter, sort, map, compact map. Okay. And so I'm going to give you an example of reduce. Reduce, you'd use reduce if you were trying to combine a bunch of values, right? So in this case, we're going to say, let nums, right? This is a very simple example. 1, comma 2, comma 3, comma 4, comma 5. So we want to add 1, 2, 3, 4, 5. We know 1 plus 2 is 3. 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. 10 plus 5 is 15. Yeah, right? If we're doing it a loop, we would say func add nums. Okay. And nums type an array of ints, right? And we return ints, right? So let's see, var sum equals 0. Now what we're going to do is we're going to iterate through the numbers, get them, and then add to sum and return all those numbers added, right? For item, and this is a loop right here, it's very simple. For item in nums, sorry, in nums, right? And of course, I'm going to say add nums, right? And then we're going to say the sum is equal to or plus equals to item. So for each one, we're adding an item, and then we're returning the sum. So this right here, sum plus equals, is the same as making sum equals sum plus item. And of course, we should be returning 15, which we are. Now, this isn't a lot of code, but if we really wanted to do this a lot faster, I'm going to say add nums 1. And once you get used to the logic, sorry, nums type an array of int. Oh my God, I hate when this does that. Int turns an int, right? It's one line. Return nums dot reduce, because this is a method of the int of the array. Reduce 0 is the number, the base number. I mean, that's where we start at, right? Just like this is where we start at, right here. And we're gonna do everything shorthand. Dollar sign, not dollar sign 0 plus dollar sign 1. And that's it. So let's test it. Add nums 1. Same answer, 15. As you can see right here, this is where it's doing the work. One line. And just so you can see what's what, we're going to do this. I'm going to say return. So you can understand what dollar sign 0 and dollar sign 1 represents. Okay. So I'm going to say print, right? Dollar sign 0, colon, dollar sign 0, right? And we'll say print dollar sign 1, colon, dollar sign 1. Now let's go ahead and run this again. So as we see, for dollar sign 0, 0, but then for the ones, of course, is every number in the array, right? 1 represents every number in the array. 1, 2, 3, 4, 5. 0 represents, you know, the sum at each iteration. That's what 0 represents. So the very first, except for the last iteration, of course, the last iteration is returned. You see 0, right? 0, 1, okay? Then 1 plus 2 is 3, right? 3 plus 3 is 6, right? 6 plus 4, right? Which is the fourth number. 6 plus 4 is 10, right? And of course, 10 plus 5 is 15, which is returned. Okay. So this 1 literally represents the elements. 0 represents the number, this number right here. This is where it starts. But dollar sign 0 represents this number, the number that's going in here. And of course, the last number isn't printed out, it's merely returned. Okay, so that's it for reduce. If you need to kind of go over it, run this over in your mind, I suggest you watch the video again, maybe even go onto YouTube and look at other videos to talk specifically about reduce. But for now, we're going to move on to the other higher order functions. On to the next.